Manage the blame for this is like
I'm going to briefly show you how to draw the Lewis structure for F2. If we follow the steps, the first step to draw Lewis structure is to write the total number of valence electrons. Fluorine is in group 7A. It has 7 valence electrons. There are 2 of them. Time 2 give you a total of 14. Step 2, you place them. This is fluorine, this is fluorine. Step 3, you connect them with a dash, which represent a single bond, a pair of shared electrons. This represents 2 electrons. I subtract them from 14, give me 12. Next step, I place them, I distribute them by pairs. I have 1 pair, 2, 4, 6, 8, 10, and 12. So I had 14, I place 14, and each fluorine is stable with 8 electrons. Okay, so those are the 2 conditions. Number 1, you need to use the total number of valence electrons. Number 2, each atom should have an octet. If it's not, an exception to the octet rule. Alright, so let's reset and do it for nitrogen. Total number of valence electrons. Nitrogen is in group 5A. It has 5 times 2 give you 10. You place your nitrogen and then you connect with a single bond. Subtract 2, you have 8 left to distribute. So I have 2, 4, 6, and 8. So I have used all 10 valence electrons. But this nitrogen is not stable because it has only 2, 4, 6. So what I should do when I run out of electrons, I need to convert a pair of unshared electrons by a pair of shared electrons. So I count 2, 4, 6, 8. This nitrogen is stable, but this one, 2, 4, 6, is not stable. So I need to go back and replace a pair of unshared by a pair of shared electrons. So I have used 2, 4, 6, 8, 10. This nitrogen is stable with 2, 4, 6, 8. This nitrogen is stable with 2, 4, 6, 8. I use the total number of valence electrons and each one is stable. This is called a triple bond. Okay, you have 3 pairs of shared electrons, triple bonds. Let's reset and do it for cyanic acid. Total hydrogen in group 1 has 1 valence electrons. Carbon in group 4A has 4 valence electrons. Nitrogen in group 5A has 5 valence electrons for a total of 10 valence electrons. Now I place them. I need to decide which one is the central atom. Which one would be the central atom? We said last time hydrogen will never be central atom. It is monovalent. It has only 1 valence electrons. So when you are confused, you don't know which one to put in the center, the one that is less electronegative will be the central atom. The other one will be terminal atoms. So, based on the trend in electronegativity increases from left to right, from bottom to top. So, fluorine would be the most electronegative. We need to check between carbon and nitrogen which one is less electronegative. It is carbon because it is farther away from fluorine. So I know my carbon will be central. And then I place my nitrogen and I place my hydrogen. Connect them with a single bond. So this is a pair of shared. A pair of shared give me 2 pairs, give me 4 electrons. So I have 6 remaining. This hydrogen is already stable with 2. Hydrogen will always be a terminal atom. So I have 6 to place. I will put 2, 4, 6. That's all I have. But this carbon is stable with 8. This nitrogen is not stable. And I don't have any more. So I have to convert a pair of unshared by a pair of shared. Alright? But look at that nitrogen. 2, 4, 6. Still not stable. So I have to go back and replace a pair of unshared by a pair of shared. This hydrogen is stable with 2. This carbon is stable with 8. This nitrogen is stable with 8. So, and I use a total of 10. They are all stable. So we have a single bond between hydrogen and carbon. We have a triple bond between carbon and nitrogen. Alright? Let's do the same thing for carbon monoxide. Let me reset. Carbon monoxide. The total is carbon group 4A, oxygen group 6A, give me 10, and I place them. There are only 2. Connect them with a single bond. Subtract 2 from 10, give me 8, and I go back. I place 2, 4, 6, and 8. That's all I have. This carbon is stable with 8. This oxygen is not stable. So I need to go and convert a pair of unshared by a pair of shared. And this carbon is stable. This oxygen is still not stable. I go back and do the same thing. Replace a pair of unshared by a pair of shared. This carbon is stable with 8. This oxygen is stable with 8. And I'm done. The formula for ozone is O3. Ozone is O3. Now, let's see how we draw the Lewis structure for ozone. Ozone, there are 3 oxygen. What is the total number of valence electrons? It is 6 for 1 oxygen. Time what? Time 3 give you 18. Alright, let me put the ozone somewhere else. Alright, so we have 18 valence electrons, ozone. And they are the same thing, same oxygen element, so I place all 3 of them. I connect them with a single bond, subtract 2, 4 from 18, give me 14, and then I place them. 2, 4, 6, 8, 10, 12, 14. Okay, I have one problem. This one is stable, this one is stable, this one is not. So I need to replace a pair of unshared by a pair of shared. So they are all stable now with 8. But this is not the only way I can draw that Lewis structure. Okay? So I can also draw it. I have my O, 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 single bond, single bond. I can put the double bond this way here, and then the single bond. And then I put my 6 dots right here, and I'm missing 2 pairs right here. When you have 2 different ways to draw the Lewis structure, you need to draw all of them, and you place 1 arrow with 2 heads between each Lewis structure. This is called resonance. Make sure you write that word on the ozone paper by that formula. If you have space on your paper, you don't have to go up and down. You can draw both of them side by side on the same line. Okay, you don't have to go up and down. I went down here because I went out of space. But you can continue right here. Put your arrow right here and draw the second Lewis structure. Okay, so remember, this is called resonance. When you have 2 or more different right ways, they have to be right to draw the Lewis structure. The only difference is you flip the single or the triple bond between them. It is found by experiment that this is not really single and double, because by experiment, this one is stronger than a single bond, this one is weaker than a double bond. All of them are the same. They have the same length and the same strength. So if I could draw this a different way, it would be, I have O, it would be something in between, intermediate. It's not really single and double. But don't worry about this way. You can draw both of them. But the bond strength and the bond length is not really 1. This is not really 2. It is 1.5 for each one of them. They have the same strength and the same length by experiment. Yes. This one. Okay, you are right. You are right. So I need to put a pair. Thank you. Alright, so this is called resonance. So why don't I challenge you? Okay, instead of me doing everything on the board right now, I'm going to challenge you on that same ozone paper. Same ozone paper. On the bottom, I need for you to write benzene. Write down the word benzene. And I'm going to give you the formula for benzene. It is C6H6. And I will tell you it is closed. Hexagon. So this one, each one is a bond. Each corner you have a carbon. Each corner. Sometimes we don't even put the carbon. They just assume you know. And then each carbon will have a bond with hydrogen. Okay, you have 6 carbon and 6 hydrogen. Now, when you count the total number of valence electrons, you will find out you have a double bond here, a single bond, a double bond, a single bond, and a double bond, single bond. Okay, instead of having something long like C, 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 it is closed. It is closed. It is called a ring. It is closed. So each one of those is a double bond. This is a single bond between the carbon and the carbon. Carbon, carbon. This is a double bond between carbon, carbon, single bond between carbon, carbon. And each carbon has a single bond with a hydrogen. Another way you can draw, there is a resonance. You see, on the same line, you can put 1 arrow with 2 heads showing a resonance. Another way I can draw it is I still put my hexagon, each corner is a C, and each C is connected with a hydrogen, single bond. Okay, you have a hydrogen, hydrogen, okay. Now, resonance. If I had a double bond right here, now I have a single bond here, and a double bond here, double bond right here, and double right here. So those two are resonances, because you just flip the single and the double bond. Two different ways to draw it. Sometimes you will see the benzene just like that. There is no need, because they are all full. This carbon, okay, so when I put that hydrogen right here, okay, if I have a hydrogen here, you see this carbon? 1, 2, 3, 4 bonds. It's full. Okay, if you look at each one of them, they are full already. There is no need for the dots. And then this is the right total. When you count the total number of valence electrons, you have the right total right here. All right? So, like I was saying, you may see something like that. Shortcut. They don't put a carbon because they assume you know each corner is a carbon. Instead of putting double, single, they just put a circle inside. That means they are not really single, double. They are what we call delocalized. The electrons are not really in a specific place. Delocalized means they don't have a specific place. They are moving around. Now, I'm leaving the last one as a challenge for you, the carbonate. On that same paper, write down the formula for carbonate and see later if you can draw the Lewis structures for carbonate, because it has more than one. What is the formula for carbonate? No. Carbonate is CO3 2 minus. We are going to practice how to draw Lewis structure with substances with a charge. Let's count the total number of valence electrons. Nitrogen has how many? 5. Plus hydrogen has 1 time 4. Good job. Excellent. Because it is positive, it lost 1. You need to add it. You need to take it away. Okay? So this is 5 plus 4 minus 1. Positive give you what? 8. So if it's negative, what are you going to do here? Add 3. Add 3. For this one you will add 2. It has extra. This one you subtract 1. This one add 1. This one add 1. Now let's do it for this one, and then you will do the rest for classwork or homework. Total we said 8. What would be the central atom? Nitrogen. It has to be, because a hydrogen will always be terminal atom. So we have nitrogen, and then we have our hydrogen. We put them as far from each other as possible, and we connect them with single bond. How many electrons have I used so far? 8. Is all the hydrogen stable? Is nitrogen stable? One more step. When it has a charge, after you draw the Lewis structure, I need for you to put the whole polyatomic ion inside a square bracket and put the charge outside the bracket. Whenever you have a charge, after you draw the Lewis structure, put it in a square bracket and put the charge outside the bracket. Alright? Let's reset. Next page. I will stop here because the recording is getting really large.